Hello dear students of plus one medical, non-medical and respected teachers. So in this video I am going to discuss what is simple pendulum and how to derive expression for time period of simple pendulum and how time period of simple pendulum depends upon various factors. So let us start with open mind. So first of all, what does it mean by an ideal simple pendulum? Ideal simple pendulum consists of a heavy point mass and heavy, consists of a heavy point mass suspended from rigid support by means of an inextensible, weightless and perfectly flexible string so that it oscillates freely about the mean position, but all these conditions cannot be achieved practically. So a heavy metallic bob suspended from a rigid support by means of a light string serve the purpose of simple pendulum. So suppose we have a bob of mass m suspended from rigid support S with the help of string. Suppose L is equal to length of the simple pendulum. So length of simple pendulum means distance between point of suspension and point of oscillation, which is the center of the bob, spherical bob. So it means SO is equal to L. So length of simple pendulum is defined as the distance between point of suspension and point of oscillation, or CG of the bob, means center of gravity where whole weight is supposed to be concentrated. Now suppose this bob is taken to a side through a small displacement y and small angle theta, that it reaches the position A. Then what are the forces acting upon this position A? Number one, weight mg acting vertically downward. Second is tension T in the string acting along AS. Acting along AS. Tension in the string acting along AS. Now, this weight can be resolved into two rectangular components, mg cos theta, opposite tension, and mg sin theta perpendicular to tension. Now this component mg cos theta balances the tension in the string, so it makes it stable, and this component mg sin theta provides the restoring force to the bob, which takes it back to the mean position, and while coming to the mean position, when it reaches to the mean position, it gains speed, it gains kinetic energy, and hence overshoot the mean position. Again, restoring force comes into play, the same component mg sin theta, and it stops at position A dash on the next other extreme, and then it is taken back to the mean position. As a result, this pendulum starts oscillating between A and A dash about the fixed point O called mean position of the pendulum. So these oscillations are simple harmonic in nature. Now we are going to prove it. So tension balances the weight mg cos theta. Since mg sin theta provide the necessary restoring force which takes the bob back to the mean position, so mg sin theta must be equal to minus ma. Cancels by negative sign because it is directed toward the mean position. It takes back to the bob to the mean position from extreme position, or a is equal to minus g sin theta. So when theta is small, sin theta is approximately equal to theta because sin 0 is 0. So when theta is small, sin theta is approximately equal to theta. Then a is equal to minus g theta, or a is equal to minus g Theta is arc over radius. L is the length, is the radius of this small arc. So it will be y upon L. So A comes out to be A is equal to minus G upon L into y. Now since G upon L is constant for a given simple pendulum and at a given place G is constant. So G upon L is constant. So A is directly proportional to minus y. It means acceleration of the bob oscillating about the mean position O is directly proportional to its displacement from the mean position and directed towards the mean position. It means oscillations of simple pendulum are simple harmonic in nature. So if the oscillations are simple harmonic in nature, then if t is equal to time period of the oscillation of pendulum, then t must be equal to 2 pi under root displacement over acceleration, which is the required general formula for time period of oscillation. Or t is equal to 2 pi under root displacement y upon a, acceleration is a at y, or is equal to 2 pi y upon substitute value of a, g upon l into y cancels. So t is equal to 2 pi under root l upon g, ignore negative sign because time is not negative. So t is equal to 2 pi under root l upon g, which is the required expression for time period of simple pendulum. And from this expression, it is very clear that time period of simple pendulum is directly proportional to square root of the length of the pendulum. Means more is the length of the pendulum, more is the time period. Number 2, t is inversely proportional to square root of g, that is acceleration due to gravity. So more is the value of g, less will be the time period. And third point is time period is independent of mass of the bob. Time period is independent of mass of the bob. So this is expression for time period of simple pendulum. Now sometimes what is seconds pendulum? So it is that pendulum which beats second. That is for which time period is 2 seconds. So taking time period is equal to 2 seconds and value of g is equal to 9.8. From this, if you calculate length of the pendulum, that comes out to be approximately 1 meter. So seconds pendulum is that pendulum for which time period is 2 seconds and length is 1 meter. So it changes with the change in length of the pendulum. Now, few questions on the basis of this expression, which is very important as far as MCQ type for competition, for NEET, IIT, and for objective type questions. Now, since T depends upon LG, the first question is, suppose a girl is swinging a swing in the sitting position. It is just like simple pendulum. It will have some time period of swing. Now, when she stands, what happens to her time period of oscillation? When she stands, what happens? What changes? Because length of pendulum changes, length of swing changes when she stands, and length will decrease because length of pendulum is defined as distance between point of suspension and point of oscillation or center of gravity. So when girl stands, then center of gravity shifts upward. As a result, length of swing or length of pendulum, you can say, decreases. As length decreases, time period will decrease. It means oscillation will become fast. So the question is, okay, what happens to time period of oscillations of a girl swinging on a swing when she stands? So time period will decrease because length will decrease. So second very important question, suppose we dug a hole along the diameter of earth and a ball is dropped into this hole. What happens to the ball? What will be the nature of its motion? Then ball will move down due to its weight, reaches center of earth, then it overshoots the center of earth. Again, there is acceleration due to gravity which always acts toward the center of earth. So since acceleration due to gravity is zero at the center of earth and maximum at the surface of earth, and G is directed towards the center of earth, because body is directed towards center of earth always. So it means both equations for simple harmonic motion are satisfied, as G is directly proportional to its displacement from mean position and directed toward the mean position. So it means the ball will start oscillating simple harmonically about the center of earth, along the diameter of the earth. So oscillation will be simple harmonic in nature, and time period of oscillation will be equal to 2 pi under root capital R upon G. Instead of length L, we take radius of earth. So when a hole is dug along the diameter of earth and a ball is dropped into it, it will execute simple harmonic oscillations, whose time period of oscillation is given by T is equal to 2 pi under root R upon G. It's very easy. So we have to see what changes, length changes or G changes. Third is, how time period varies when pendulum is taken. We are performing an experiment in air. The same pendulum is taken to the vacuum. What will happen to the time period? In air or in vacuum, what change will occur? So in vacuum there is no friction, so oscillation, there is no opposition, so oscillation will become fast, that is time period will decrease. Then what happens when pendulum is taken in water? In water, so resistance will be more, so oscillation will become slow for the same pendulum. So it depends upon nature of the medium in which the pendulum is oscillating. Time period may decrease or increase depending upon density of the medium, depending upon the opposition. Another important question, suppose we have a hollow ball filled with water suspended from rigid support with the help of a string, and it is made to oscillate like a simple pendulum. It has some time period of oscillation. Now then a fine hole is made at the bottom of the ball, so that water starts coming out of the ball and it is oscillating. Now what happens to the time period of oscillation of the ball when a small hole is made at the bottom of the ball? No, as water starts coming out of the ball, top part of the ball starts it becomes empty. As a result, center of gravity, which was at the center of the ball when it was fully filled, starts moving down. As a result, length increases, means time period increases. When the whole ball is empty, whole water comes out of the ball, then again center of gravity shifts to the center. Time period decreases, oscillation becomes fast. It means in this case time period first increases and then decreases to the same value. So this is another important question. So this is all about time period of simple pendulum and some questions upon which how time period of simple pendulum will change. So I think you have understand this topic, and this topic is very important. So till next video, be happy, good luck, stay tuned, all the best, Sarbat Tapala, good luck.